Select the graph that incorrectly represents how the velocity of an electron in an orbit of a uni-electron species is related with the principal quantum number or atomic number. Velocity of nth orbit is equals to v by n into z. That means velocity of nth orbit is directly proportional to z. Velocity of nth orbit is inversely proportional to n. Based on this, fourth graph is wrong. Select the correct statements from the list given below. The number of m values for a given n are n square. M values, magnetic quantum number value for a given n. This statement is correct. For example, n is equals to 1. In the first orbit, 1s orbital is possible. 1s orbital is possible. For 1s orbital, m value is equals to 0. That means 1 value is possible. M values otherwise, m values is equals to 2l plus 1. 2 into 0 plus 1, that is equals to 1. Second orbit, 2s, 2p. N value 2, possible m values for s orbital, m value possible is 0, p orbital minus 1, 0, plus 1. Total possible values 4. N is equals to 3. 3s, 3p, 3d. Here one value is possible, that is 0. Here possible m values minus 1, 0, plus 1. Here possible m values minus 2, minus 1, 0, plus 1, plus 2. Based on this, first option correct. The number of electrons spinning in clockwise direction of a 3px, only 3px they consider. This is p subshell. P subshell contains 3 p orbitals, px, py, pz. In px, only one clockwise electron is present. So based on this statement is wrong. The orbital with n is equals to 3, l is equals to 1, m is equals to minus 2. This is also wrong. Why that is wrong? Because if l value is equals to 1, L value is equals to 1, possible m values are minus 1, 0, plus 1 only. Minus 2 value is not possible. The Ein wave function psi 200, that psi 200, it can be written as NLM. Psi NLM, principal quantum number value 2, azimuthal quantum number value 0. Principal quantum number 2 value means second orbit. Azimuthal quantum number value L is equals to 0 means s orbital, s subshell. So fourth one is also correct. Select the correct statements. LIF is more ionic when compared to MgO. Cation with low charge. MgO, cation with high charge. Low charge favors ionic bond. So this statement correct. HCN, HC triple bond N. In this, only covalent bonds are present. Only covalent bonds present. So that's the reason this option wrong. SO2 is an electron deficient molecule. Check it. SO2. Sulfur group number 6. Oxygen valency 2. 2 oxygens 4. 6 plus 4 is equals to 10. It is electron rich, not electron deficient. Mu total CH3Cl is greater than CH3F. Correct. Only A and D are correct. The maximum number of planar atoms are present in C6H6. Carbon atom undergoes sp2 hybridization. This geometry only trigonal planar. trigonal planar. That means 6 carbon atoms, 6 hydrogen atoms are in same plane. 12 atoms are in same plane. You can consider SF6 molecule. SF6 molecule sulfur, fluorine, 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 octahedral, fluorine, fluorine. Only these atoms are present in same plane. Total 5 atoms are present in same plane. For example, you can consider but2-ine. In case of but2-ine, CH3, CH, H, H, C triple bond C, CH3. How many atoms are in same plane? How many atoms? Total 6 atoms. Here 4 carbon atoms, 2 hydrogen atoms. You can consider PCl5 molecule, phosphorus, chlorine, chlorine, chlorine. 4 atoms are in same plane. Remaining 2 chlorine atoms are present above and below the plane. Based on that, first option correct. The number of moles of KMnO4 required to oxidize 0.5 moles of ferrous oxalate in an acidic medium. First of all, KMnO4 acidic medium reaction. KMnO4 reacts with H2SO4, then it is converted to MnSO4. Calculate the N factor value. +7 in KMnO4 manganese oxidation state +7. In MnSO4 manganese oxidation state +2. Oxidation number difference 5. 1 manganese atom is there, so multiple with 1. 5 into 1 is equals to 5. N factor value 5. Ferrous oxalate FeC2O4. In this is ferrous oxalate. Ferrous salt is converted to ferric salt. Oxalate ion converted to carbon dioxide. Now calculate. In a molecule, 2 different atoms undergoes oxidation and reduction. X is equals to +1, x is equals to +2, x is equals to +3. Oxidation number difference 1. Process is oxidation process. Only 1 iron atom, multiple with 1. N factor value 1 here. Here calculate. 2x minus 8 is equals to -2. 2x is equals to 6. X is equals to +3. Here x is equals to +4. +3 to +4. Oxidation number difference 1. How many carbon atoms are present reactant side? 2 carbon atoms. So multiple with 2, that is equals to 2. Remember one point. In a molecule, two different atoms are +2 to +3, +3 to participate in oxidation process. Then NF is equals to NF1 plus NF2. NF1 value 1, NF2 value 2. 1 plus 2 is equals to 3. Now for balancing equation, exchange the coefficients. Exchange coefficients or exchange N factor values. Exchange N factor values. So 3 moles of KMnO4 requires 5 moles of FeC2O4. Then 0.5 moles of ferrous oxalate. How many moles of KMnO4 required? 0.5 into 3 by 5. 0.3. So first option correct. The number of significant figures in 5.0201. 5.0201. What is the condition? Significant figure rule is 0 between non-zero digits are significant. So based on this, 1, 2, 3, 4, 5. All 5 are significant. A swimmer coming out of a swimming pool is covered with a film of water weighing 80 grams. Water weight is given here 80 grams. The amount of heat in kilojoules that needed to evaporate this water is, enthalpy of vaporization of water is given 40.79 kilojoule per mole. We know that 1 mole is equals to molar mass. Molar mass of water is equals to 18 grams. So for 18 grams of water, 40.79 kilojoule per mole of heat is required. Then 80 grams of water, how much heat? 80 into 40.79 divides with 18. Simplify, you will get 181 kilojoules needed. First option correct. 1 mole of an ideal gas undergoes a change of state 2 atmosphere 3 liters to 2 atmosphere 7 liters. That means P1 2 atmosphere, even P2 also 2 atmosphere. There is no change in pressure. And volume V1 is equals to 3 liters, V2 is equals to 7 liters. With a change in internal energy, delta U value is given 30 liter atmosphere. Then calculate delta H value. How much? The relation between delta H and delta U. Delta H and delta U is delta H is equals to delta U plus delta nRT. Given condition is ideal gas condition. For an ideal gas, PV is equals to nRT, or here pressure remains constant. P delta V is equals to delta nRT. Substitute, then delta H is equals to delta U plus P delta V. Delta U value is given as 30 plus pressure remains constant, volume change delta V is equals to V2 minus V1, 7 minus 3, 7 minus 3 is equals to 4, to 4, 30 plus 8, that is equals to 38 liter atmosphere. But what is the question answer in terms of kilojoules? We know that 1 liter atmosphere is equals to 101.325 joules. Now 38 liter atmosphere is equals to how many joules? Then 38 into 101.325. Simplify, you will get 3849.4 joules. In terms of kilojoules, 3.849 kilojoules. Second option correct. When CO2 gas bubbled through water for some time, The following equilibrium is established. CO2 plus 2 moles of H2O gives rise to H3O plus HCO3 minus. We know that Kc is equals to ppc by prc, product of product concentration by product of reactant concentration, concentration of H3O plus into concentration of HCO3 minus by concentration of CO2 into H2O concentration whole square. Or it can be also written as concentration of H3O plus Kc is equals to HCO3 minus by concentration of CO2. Neglect H2O. What about this? Neglect, exclude or exclude the concentration of pure liquids and solids. Now what is given? Kc value is given. Kc value is given as 3.8 into 10 power minus 7. pH value is given as 6. Then H plus ion concentration is equals to 10 power minus 6. Or it can be written as H3O plus ion concentration is equals to 10 power minus 6. H3O plus concentration is 10 power minus 6. HCO3 minus by CO2. Now finally HCO3 minus by CO2 ratio is equals to, here multiple this side divided 3.8 into 10 power minus 7 by 10 power minus 6. 3.8 into 10 power minus 1, it can be also written as 0.38. Select the correct statement from the list given below. pH of m by 100, 1 by 100 molar NaOH. That means 10 power minus 2 molar NaOH. pH value, OH minus ion concentration is equals to 2. Then pH, OH minus ion concentration is equals to 10 power minus 2. Based on this, pH is equals to, POH is equals to 2, pH is equals to 12. So first statement correct. M by 100 H2SO4, 1 by 100 molar H2SO4. Now pH, pH is equals to negative log of H plus ion concentration. H plus ion concentration means Mk, molarity into valency. Molarity is 10 power minus 2. Valency, number of replaceable hydrogen atoms 2. So you will get 1.6990, not 2. So second statement wrong. Third statement, pH of M by 100 CH3COOH is between 2 to 7. Yes, this is correct. Between 2 to 7. Why between 2 to 7? Because CH3COOH is weak acid. Weak acid, not 100% ionizable. pH of M by 100 molar NaCl is 7. This is also correct because NaCl is a combination of, NaCl is a salt of HCl and NaOH. Strong acid, strong base combines to give NaCl. This is neutral salt. Neutral salt's pH value is equals to 7. So A, B, C statements are A, B, D, not A, B, D. B statement wrong. A statement correct, C statement correct, D statement correct. So second option. A, B, C, D salts KSP values are given. Solubility is maximum in, first of all, given AB type of salt, KSP is equals to formula S square. If you want solubility, S is equals to square root of KSP, that is equals to square root of 10 power minus 10, 10 power minus 5. Solubility is. Second salt is given as AB2 type of salt, KSP is equals to 4S cube. Then S is equals to cube root of KSP by 4. So cube root of 10 power minus 10 by 4. This value is less than 10 power minus 5. Cube root of 10 power minus 10. Otherwise do one thing. This is square root of 10 power minus 10. This is cube root of 10 power minus 10. Next one. A3B2 KSP is equals to 5. No, not 5. 108 S power 5. Then S is equals to fifth root of KSP by 108. That is fifth root of 10 power minus 4 by 108. This is AB3 type of salt. KSP is equals to 27 S power 4. S is equals to fourth root of KSP by 27. So fourth root of KSP 10 power minus, sorry, all these are 10 power minus 10s. 10 power minus 10. 10 power minus 10 by how much? 27. So based on this, the correct answer is maximum solubility. Maximum solubility means less value. 10 power minus 10. Yes. Third option. C is maximum soluble based on solubility values. Select the correct statements. SnF4, PbF4 are ionica, whereas PbI2 is covalent. This is correct only. PbI2 is covalent because of inert pair electron effect. SiCl4 reacts with H2O excess, gives X. The X reacts, X on heating gives SiO2 plus H2O. SiCl4 reacts with H2O excess. HOH, take 4 moles of water molecule HOH, HOH, take 4 moles of, remove 4 moles of HCl, then SiOH taken 4 times. SiOH taken 4 times plus 4 moles of HCl. SiOH taken 4 times on heating gives SiO2 plus 2 moles of H2O. This statement is also correct. The density of graphite is less than that of diamond. Correct. In BF3, boron atom undergoes sp2 hybridized. Correct. All the statements are correct statements only. Two liquids A and B have vapor pressure in the ratio of PA naught by PB naught is equals to 1 by 3 at a certain temperature. Assume A and B form an ideal solution and the mole fraction of A and B in vapor phase. Vapor phase mole fraction of A and B is given. Ya by Yb value is equals to 4 by 3. Then the mole fraction of B in the solution state at the same temperature is. In vapor phase, the relation between partial pressure and mole fraction is Ya is equals to P naught A by P total. Yb is equals to P naught B by P total. So sorry, in vapor phase Ya is equals to PA by P total. YB is equals to mole fraction of B is equals to PB by P total. This is taken as equation 1. This is taken as equation 2. YA by YB is equals to PA by P total into P total by PB. P total get cancelled. YA by YB is equals to PA by PB, or it can be also written as YA by YB is equals to P naught A XA by P naught B XB. YA by YB value is 4 by 3. P naught A by P naught B value is 1 by 3 into mole fraction of A by mole fraction of B. Then mole fraction of A by mole fraction of B is equals to 4 by 3 into 3 by 1. 3 cancel. Mole fraction of A by mole fraction of B is equals to 4. What is the question? Then the mole fraction of B is, okay, mole fraction of A. Based on this, mole fraction of A is equals to 4 into mole fraction of B. We know that according to mole fraction, XA plus XB is equals to unity 1. XA is equals to 4XB. 4XB plus XB is equals to 1. 5XB is equals to 1. Then XB is equals to 1 by 5. So first option correct. RLVP is highest for an aqueous solution of. RLVP is directly proportional to number of solute particles or want half factor value. Urea dissociation is not possible, so 1. Number of solute particle. NaCl dissociate Na plus plus Cl minus. Want half factor value 2, or number of solute particles 2. Number of moles dissociated like MgCl2, Mg2 plus plus 2Cl minus, AlCl3, Al3 plus plus 3Cl minus. So here 4. So highest RLVP is directly proportional to number of solute particles. So fourth option correct. Limiting molar conductivity of Al3 plus. Cap naught Al3 plus value is given X, and cap naught SO4 2 minus value is given as Y. Calculate limiting molar conductivity. Cap Al2 SO4 thrice, how much? Al2 SO4 thrice is a combination of 2 Al3 plus 3 SO4 2 minus. Each Al3 plus value is X. Each Al3 plus molar conductivity 2 into X plus each SO4 2 minus molar conductivity is Y. So 2X plus 3Y is correct answer. The time required for the complete decomposition of 4 moles. Number of moles is given as 4 moles. Amperes, current in amperes is given as 4 amperes. Time in seconds is equals to question mark. According to Faraday's laws, IT by 96500 is equals to number of moles into K. What is K? Number of replaceable H plus or OH minus ions. Current in amperes 4, time in seconds calculate by 96500 is equals to number of moles 4 into H2O case. H2O dissociate to give H plus and OH minus ions. 1 H plus and 1 OH minus. 1 plus 1 is equals to 2. So K value take it as 2. Then T is equals to 4 into 2 into 96500 by 4. 4 get cancelled. Simplify. Then you will get 193,000 seconds, or it can be also written as 1.93 into 10 power 5 seconds. Second option correct option. For a certain reaction, for a reaction A plus 2B gives rise to C, the experimentally verified rate equation is rate is equals to K into A into B. Concentration of A into concentration of B. If the concentration of B is doubled, keeping the concentration of A constant, the value of rate constant K at the same temperature, we know that K value depends on temperature. Here what is given? K value, sorry, temperature remains the same, constant. Then there is change in rate constant. First option correct. Consider the plots of the type for the reaction Na gives rise to B plus C. This is the first graph. First graph is between minus dA by dt and concentration of A. We know that it is first order reaction graph. How? Rate of reaction, if it is first order, rate of reaction is equals to K into A power 1. Rate with respect to A, or it can be also written as minus dA by dt is equals to K into A, form of y is equals to mx. This is the second graph. Second graph represent zero order reaction. Zero order reaction, how it is zero order? We know that integrated rate equation K is equals to R naught minus R by T, or it can be also written as minus A by T, or KT is equals to A naught minus A. A is equals to minus KT plus A naught. This is in the form of y is equals to mx plus c. Slope is negative slope, so it is zero order reaction. First one is first order, second graph is zero order, 1 0. Fourth option correct. Possible, select the correct combination. Possible oxidation state of chlorine in its compound is -1 +1 +3 +5 +7. Correct. If you want example, HCl, HClO, HClO2, HClO3, HClO4. Possible oxidation state of sulfur in its compounds is -2 +2 +4 +6. This is also correct statement. Possible oxidation state of nitrogen in its compounds is -3 +3 +5. Wrong. -3 to +5 is possible. If you want examples, -3 to +5, N2H4, NH2OH, N2O, NO. Oxides of nitrogen. You can take oxides of nitrogen and calculate the oxidation state of nitrogen. So C statement wrong. Possible oxidation state of oxygen, its compound is -1. -1 is possible in case of peroxides. -2 is possible in case of oxides. 0 is possible in elemental state or uncombined state. +1 +2 is possible in oxyfluorides. In oxyfluorides, oxygen exhibits positive oxidation state. But this statement is also wrong. Why? Because in peroxides, one more oxidation state is possible. In peroxides, oxygen exhibits -1/2 oxidation state. So based on that, A, B statements are correct. Find the set from the following in which all are essential amino acids. One letter code of amino acids are given. All must be essential. Fourth option correct. V indicates valine, essential amino acid. K indicates lysine, essential amino acids. W indicates tryptophan, essential amino acid. In the titration of KMnO4 versus oxalic acid in acidic medium, which one acts as indicator? In KMnO4 reactions, KMnO4 acts as self-indicator. A colorless salt gives brisk effervescence with dilute H2SO4. Brisk effervescence. Brisk effervescence are obtained. That is, the salt is carbonate salt. Why brisk effervescence are obtained? Carbonate salt releases carbon dioxide gas, CO2 gas. Brisk effervescence are obtained with dilute H2SO4 and crimson red color in the flame test. Crimson red color is strontium. So strontium carbonate. Third option correct. Flame colors of 2A group. Beryllium, magnesium, both are colorless. Calcium, brick red. Strontium, crimson red. Barium, apple green. The given complex can exhibit which type of isomerism? First one is given as CrH2O taken thrice, NH3 taken thrice, 3 plus. This is look like Ma3B3. Ma3B3 exhibits fascial and meridional isomerism. That means geometrical isomerism. Next one. Cr En taken thrice, 3 plus. En is a bidentate ligand. Bidentate ligand, donor atoms, nitrogen, nitrogen. Donor atoms remains the same. So bidentate ligand is present, donor atom remains same means This is symmetrical bidentate ligand or didentate ligand. Symmetrical bidentate ligand is present. It exhibits only optical isomerism. Optical isomerism. You can take one more compound, Cr, Gly, taken thrice. Glycinato. Gly means glycinato. NH2, CH2, COO minus. NH2, CH2, COO minus. Donor atoms, nitrogen and oxygen. Different type of atoms. So this is considered as unsymmetrical didentate ligand or bidentate ligand. So unsymmetrical, if the bidentate ligand is unsymmetrical, it exhibits geometrical isomerism and optical isomerism. Based on that, third option correct. Which of the following conversion is exothermic? You can see neon, already NH2 NP6, stable electronic configuration. If you can add one electron, then it is converted to Ne minus. Addition of electron requires energy. Why? Because it is stable electronic configuration. So this conversion is endothermic. Mg converted to Mg2 plus. Mg, NH2 electronic configuration. NH2 is also stable electronic configuration. To remove one electron, minus electron, then it is converted to Mg plus. Already initial electronic configuration is stable electronic configuration. NH2 NP6 also stable electronic configuration. From stable electronic configuration, you are removing electron or addition of electron. If initial concentration is stable, then the reaction is considered as endothermic reaction. Why? Because at the time of addition of electron, energy requires. Remove electron, energy requires. Why? Because already initial configuration is stable. Next, sodium converted to sodium plus. Sodium electronic configuration neon TS1. It loses one electron, then it is converted to neon configuration. Stable electron, unstable converted to stable. Unstable converted to stable, most stable. Then here also, to remove one electron, it is ionization energy. Remove one electron. Ionization energy. Ionization energy, here also energy is required. So endothermic reaction. Remaining only one second one. Li converted to Li minus. Li initial configuration is stable? No, unstable. That's the reason initially unstable configuration. So it is exothermic. Addition of electron is called as electron affinity. Addition of electron is called as electron affinity. Removal of electron is called as ionization energy. Incorrect statement among the following. The most electronegative element is aluminum among 13th group. This is only incorrect. Not aluminum. Boron is more electronegative element. The crystal field splitting of the Cr3 plus ion in octahedral field changes for ligons I minus H2O NH3Cn minus, then the correct order of increasing splitting is I minus less than H2O less than NH3 less than Cn minus. Once check the spectrochemical series order. Spectrochemical series order. Benzene treated with CH3COCl, Friedel-Crafts acetylation, then it gives C6H5COCH3. COCH3 is electron withdrawing group. It undergoes nitration, then meta position substitute NO2 group. So statement 1 is correct. NO2 group is meta directing group and deactivating group for electrophilic aromatic substitution reaction. Correct. Both the statements are correct. EAS, electrophilic aromatic substitution. The best reagent to carry out the following conversion. What happened? Aldehyde group is converted to alkane. Aldehydes are converted to alkanes, means undergoes reduction. Here two reactions are there. One is Clemmensen reduction. Second one is Wolff-Kishner reduction. Question is best reagent. Best process is Wolff-Kishner process is best process. N2H4 is the best reagent. Why not zinc amalgam HCl? Why not Clemmensen? Why not Clemmensen? Why only Wolff-Kishner? Why not Clemmensen? Because Clemmensen reaction takes place in the presence of strong acid. Under acidic conditions, degree alcohols participate towards dehydration reactions. Combination of alkane is free radical substitution reaction. 3,3 dimethyl hexanone 1 2 3 meth eth prop but and hex. First position double bond, second third fourth position triple bond. 3,3 dimethyl 1 2 3 3,3 dimethyl. How many sp3 hybridized carbons? sp3 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 sp3. 4 sp3 hybridized carbons. How many sp2 hybridized carbons? sp2. This is sp2. This is also sp2. 2 sp2 hybridized carbons. These two are sp. So first option correct. Following the number of reagents that affects the given conversion. This is 2 degree alcohol. 2 degree alcohol converted to ketone. That means weak oxidizing agents PCC, PDC are affected. PCC, PDC are affected. KMnO4 by H2SO4 does not affect. Why? Because this is very strong oxidizing agent. So unaffected. Br2NaOH 2 degree alcohol, it participates towards haloform reaction. This is also unaffected. Product is different. Participate towards halo form reaction and it gives halo form. Iodo form is the product. Here KMNO4 H2SO4 very strong oxidizing agent. Carboxylic acid is formed as a product. Alkaline KMNO4 no dihydroxylation takes place. Only two reagents are suitable for this conversion. Which of the following compounds least likely to give effervescence of CO2 in the presence of NaHCO3? Sodium bicarbonate test. Which gives sodium bicarbonate test? Carboxylic acids gives sodium bicarbonate test. Sulfonic acid also gives sodium bicarbonate test. Picric acid. Why? Because this is picric acid is a strong acid compared with carboxylic acid. Also gives sodium bicarbonate test. This is picric acid. It gives carboxylic acid gives phenols does not gives because it is phenol does not gives. Phenols reacts with only NaOH. Alkyl halide reacts with the phthalimide. Then it gives amine, aliphatic amine. Aliphatic amine. What is the reaction name? Gabriel phthalimide synthesis. Hyperconjugation is not a permanent effect. This is wrong. Hyperconjugation is a permanent effect. So first statement wrong. Carbocation stability increases with an increase in the number of alpha CH bonds due to enhanced hyperconjugation. This is correct. Statement 1 incorrect, but statement 2 is correct. Only electromeric effect is temporary. Remaining all effects are permanent. Allotrope of carbon used as a filler in automobile tires is carbon black. Formalin is 40% formaldehyde solution is formalin. The Geldar's method is not applicable to direct pyrrole. Carbocation sp2 hybridized carbon with empty p orbital A3. Methyl free radical. Free radicals are paramagnetic and contains one unpaired electron. B4. Nucleophiles. Species that can supply pair of electrons. C1. Automatically electrophile. D2. Fourth option correct. Which of the following alcohols cannot be prepared from the hydration of alkenes? Okay. OH group attached carbon. This is 2-degree alcohol. This is 3-degree alcohol. This is 1-degree alcohol. This is also 1-degree alcohol. Generally, 1-degree alcohols cannot be prepared by this method. So, first one possible, no doubt. Second one possible. Actually, third one is also possible. How third one is possible? CH2 double bond CH2. Symmetrical alkene. Add water molecule. Then it gives ethyl alcohol. CH3 CH2OH. But fourth one is not possible. Why? After that, immediately a quaternary carbon atom is present due to steric strain, steric hindrance. Cyanide reacts with the SnCl2 plus HCl. Further hydrolysis. Reaction is Stephen reduction. gives aldehyde as a product. The maximum oxidation state possible for uranium plus 6, neptunium plus 7, plus 6 plus 7. Even plutonium also exhibits plus 7 oxidation state in actinides. Actinides, neptunium and plutonium are exhibits plus 7 oxidation state. Plutonium exhibits plus 7. Which of the following statement is correct for a 3D transition element? All the metals except scandium forms MO oxides. SCO is not possible. Scandium exhibits plus 3 oxidation state. That's the reason. First one. Incorrect statements. Propene, meth, eth, propene shows geometrical isomers. No. A statement incorrect. The trans isomer has identical atoms or groups on the diagonally opposite side of the double bond. Correct. Cis-butene has a higher dipole moment than trans-butene. Correct. 2-methyl-butene shows two geometrical isomers. Wrong. Meth, eth, prop, but. 2-methyl-butene no, does not shows. The trans isomer has lower melting point than the cis isomers. This is also wrong. Question is related to incorrect statements. A, D, E are incorrect. Assertion: alkyl fluorides are more reactive than alkyl iodides towards nucleophilic substitution. Wrong. SN1, SN2. Both cases alkyl iodides are more reactive. After that alkyl bromides, alkyl chlorides and alkyl fluorides. The living group ability of iodide is more than that of fluoride. Correct. A false, R true. Which of the following aryl amine undergo diazotization with great difficulty? Great difficulty. Diazotization. Proportional to electron withdrawing group. Electron withdrawing group is present. So first option. Directly proportional to electron donating groups. NO2 is strong electron withdrawing group. That's the reason first option. Thank you.